Hello everyone, welcome back to another video. Today I want to share with you my answer to my takeaway assignment number one for this semester. It's about predicting Airbnb prices in the Vancouver area. They give us a data set and we have to do the data cleaning, transformation, regression modeling, and regression evaluation. So I want to guide you step by step for through my reasoning, everything that I have done here to answer this. And if you want, I will leave the code down below, the GitHub link to the code. So if you want to see it, it will be there. Okay. So the first things that we normally do is import the library. For example, pandas is a go-to for these things. Nowadays we can use Polar, but Panda is fine. We import the dataset and take a glimpse to the dataset, and we can see that I have like 79 columns, and the columns are like this. You can see that we have some unstructured text, we have some URLs, we have some numbers, we have some I would think that this will be like Boolean, true or false, and we have a lot of stuff. Reviews per month, radio, maybe, something like that, and we have a lot of stuff. The first thing always is to check for the shape of the data frame to see how many columns and rows do we have. So we have 4,700 columns, so 4,700 columns and 79 rows. So I want to see which are the rows that we are dealing with. And for example, here now, at first sight, I see that I have to remove a lot of this column because it won't give me much information. For example, URLs, the ID, the picture URL, all this stuff has to remove because I don't think that I will get like too much information from this. So another thing that I want to do is check for the information of this data frame. So here is another very important information that we can see. For example, we have neighbor group clean set, like we have zero non-null elements. So this column is completely empty. So we can remove this one, and if there is another one, we can remove it as well. I want to see the mean of all the values that have nulls to see how many values with null for each column, and I want to see the first 25, and I see that we have these two have no value at all, and the rest is not that bad. So the first thing is data cleaning. After a long time of reviewing these columns and try to figure out which one will give me the best information, I ended up with these 9 scenarios. I will remove completely the columns that have zero known values. So these columns are empty, so they have no information. I will remove every identifier as URL, listing ID, host ID, all the columns that have this information. I don't think it will bring me any more uh, information from my regression model, so I will extract it as well. There's some scraping metadata, such as scrape datetime source, all the stuff that maybe when we were collecting this data, we were doing some wet scrapping or something like that. And all this data come into our data set, so I'm going to delete it as well. I will delete also unstructured text as host name, for example, description, all that stuff. Maybe description, if we do like something like NLP, will be like some beneficial, but in this case, we are going to try to make a regression model, so I will remove it as well. About the host, all that stuff, I will remove it. We're also going to remove any missing data or duplicate rows that are in our columns. For example, in neighborhood, when I say duplicate, I refer like duplicate columns. For example, neighborhood and neighborhood clean set is like the same. Bathroom text versus bathroom is the same, just that one is with text and the other one's with numbers. So I will remove one of those. I will remove redundant aggregation and the fields. This was like, okay, for example, I have some columns like available 30 days, available for 90 days, available for 25 days, available for 365 days. All that column, I will remove it and keep it one. I will remove all about the location, commutation, cleanness, all that stuff. Even this column maybe give us some information. I think we already have like the rating column that include all of those. So I will remove those columns too. Here is how I remove all those columns. For example, I create my columns to drop like an empty list, and then I go one of each these scenarios and detecting the columns related. For example, I want to remove neighborhood glimpses, calendar updated because they are completely empty, the URLs, all the columns with URLs and IDs, the scraping metadata, unstructured text, all those columns, I will remove it from my data set. So at the end, I ended up with 29 columns out of 79 that I have at the beginning. So now I have all the columns that I want to work with. So the first thing is I want to identify the price, right? So I'm going to clean the price column. Why I have to clean it? Because if you go to the data set, you will see that the price is not like a number. It can like a string and it have like this string symbol at the beginning. So I have to create a new column price that is a number so I can use it in my regression model. So I do a lambda function to remove this dollar sign from the beginning and convert the result into a float so I can have decimal points, and that's a dollar amount. So then I want to see the distribution of this column. And we can see that at first sight, you can see like, whoa, this is like not very good because we only have like this big bar over here and we don't have any more data. But that's actually not the case because what is telling me this graph is like we have a really long outlier in this area over here, and it's too small that you can even see it. So we have to go and check for outliers. The first thing that I try to picture is to find the outliers was a box plot. So here you can see that we have like a lot of prices below $10,000, and we have only one here above the $40,000. So we have a very distant outlier that we probably want to remove so we can do like a better regression model. Other thing that I did was to only keep those within the 99% quartile. So I have all my data that is in the 99% quartile because this data over here is like way outside of my data. So I clean it and still remain with a lot of outliers, but that's okay. I think we can work with that. As you can see, that's what I did here. Describe my percentile, my outliers. So once I remove the outlier, the 40,000 outlier, now we have this other graph representing the distribution of our prices. As you can see, these have like a really long right tail, like a skewing to the right, skew to the right. So we need to perform some transformations in this price variable so we can have like a more normal distribution so we can try to have a better predictor for this price variable. There are two main transformations that we can apply to this, and one of the transformation is the logarithmic transformation and the other one is the Box-Cox transformation. In this assignment, I will treat both. I will treat with logarithmic and with Box-Cox, and I will see which one perform better. So in this scenario, we see like we perform a logarithmic transformation. We can see that we have like more normal distribution, but we still have like a long right tail. to the end. So I think the get better will bring me better result, but I'm not so sure right now. The second transformation that we can apply, as I mentioned, was the Box-Cox. We can see that with Box-Cox, we can have like a better normal distribution. And we will perform a regression targeting these two variables, the Box-Cox and the log transformation, and we will see which one is better. After that, I went to analyze the rest of the variables that I have on my uh, data set. For example, latitude, longitude, how many accommodates we have, bathroom, how many bathrooms, how many beds, how many, the minimum 9 that requires, the maximum 9, the reviews per month, all that stuff. And we can see here that we have in the variables other variables that have like right or left skew. So we have to treat those variables too. Here we are seeing trying to identify the degree of skewness from each column, and we see that this one here has a lot of skew to the left or to the right. Another thing that I did was transform these variables with a lot of skewness to the left or to the right with another transformation method. This method is the Geo-Johnson. And why I choose this Geo-Johnson method? Because this variable, latitude, longitude, all these variables that I will be applying uh, this transformation, reviews per month, all the stuff, have negative data. And Box-Cox is unuseful to treat negative values. So that's why I use the Geo-Johnson method. Now we pass to the cleaning of these variables. The first thing, I split my data set into the numerical variables and categorical variables. So the first thing was to identify the numerical variables, that I did it with this. I select everything in my dataset that have type NP number, and number will be like anything, like integer, float, anything, it will be a number. And I have 16 columns in this dataset that are numbers. So the first thing was to identify the correlation among my variables. So I can see if I can drop any other column, because if we have two or more variables that have a high correlation between them in the feature set, I think we can remove one of those and keep the other one. So when we we can make a graph of this correlation matrix, and we would see that we have like this huge cluster over here from variables that are highly correlated. So we can remove these variables and keep only one of those. For example, we can remove bathroom, bedroom, and bed, and keep only accommodates, and it will work just fine, because these four variables are very correlated among them. That's what I try to show you here, that the correlation is very high among those variables. So at the end, for my regression model, I only will keep variables with correlation below 75%. Then we want to the categorical feature. We want to the cleaning of my categorical features. This is a little bit more complicated, but not too complicated. So I will try to explain my best here. First thing, to see the categorical variables, we see here that we have, for example, a date, since when the host is been in Airbnb. We can transform this into a number. For example, how many years the host has been in Airbnb. So we can transform this date into a number. Host response time. We have to see how many different these labels are. So are few or there's many. So we can transform this into a number too. The host response rate is percentage. We can convert it to a number too. Host verification, we can convert this into, for example, a number of how many verification method the host has. This we can transform into true or false. We have this amenity here that I am thinking this is like a JSON, a list or something, and we have to do something with this amenity too. The price, we will remove it after, and we have ability true or false. And the license, I'm seeing this is like an HTML. I will convert it to has license or it doesn't have a license. Let's start by removing the price. We don't need the price because we already have like our clean price and a log price and Box-Cox price. So we can remove the price. Transform the host since to host years. How many years do we have uh, this host in Airbnb? So we can see like the longevity of this host. Other thing that I did is convert the rate and the acceptance rate to numbers, the same thing that we did with prices. Convert the columns, the Boolean columns that we have, like true or false, convert it to 1 and 0. 1 is true, 0 false. Host verification, with, as I mentioned, we transform into a number because we see that we have email, phone, work email, and other ones have only emails and phone. So I transform that into the length of this list to see how many uh, verification types the host has. The response time, we can see the first thing was to see how many different response time it was, like a few days within a day, a few hours within an hour. So I map these four because there's only four. I map into the number 1, 2, 3, 4, and if there is not any response, I will put like another number. I convert that. Has license. I was we see up there that it was like an HTML. I transformed into, if there is something there, I will assume there is a license. If there is not a number or anything like that, is I will assume that the user has not a license, does not have a license. So true or false. Room type, we see that there is only these three room types. I did exactly the same with room type that as with response time. Property type. Property type is different because we have a lot of different property types. What I did here was select the first five because it are the ones that have the most. And the rest, I put it like others together. I select the first five and the rest I put it like others. And now we want to try to see what is inside amenities. And if you go to amenities, you see that there is like a lot of miscellaneous things inside the house or the Airbnb. Like if I have a bathtub, I have shampoo, refrigerator, toaster. So they have a lot of variables here that are not very common. So the thing I did was to select 4 or 5 that I think was like the most engaging. We can like try to run it again with another amenities and see what happens. But I only select like try to see if the house has a Wi-Fi, if I have a kitchen, have heating, have air conditioning, have parking. With those 5 variables, I think it was okay for me, so I continue with that. Yeah, at the end, once I done with the amenities, I join my two dataset again, the numerical part and the categorical part, into a final dataset, and at the end we come again to 35 columns. Now that I have all these columns split, I have all my dataset clean. I go to the train test split. This is the easy part. Here, the first thing that I did was to remove log price and box price because I have price cleaned, and I will do the transformation later. So my training set will be everything except the target, and my target it will be like the price cleaned. Okay, so I clean here. I train split, I train and split, and now that we have that, I have to check for any missing value, anything that could broke my my pipeline of training. So that's what I did there. And now, once that I have the train set split, Now is that I'm going to apply the transformations in the variables. For example, I want to apply the transformation here for a Box-Cox and a transformation for logarithmic. So now I have here a variable with price with Box-Cox and variable price with log transformation. Okay. Now I'm going to transform the columns, the categorical columns. How I transform the categorical columns? First, I input the missing values. For example, half review. It was created because review scoring have different things like percentages and all that stuff, and I changed it to half review. Review score ratings. There was like a lot of columns a lot of rows that doesn't have review because maybe the house is new or something like that, and I just fill it with 0. If not have any review, I will say the review is 0. For host response rate and host acceptance rate, I decided to go with the medium because I don't want to include any bias on my final result. So I go with the medium to not remove all the data. And the binary columns, I just fill it with false. So how I proceed to encode the variable? So I encode my variable with one hot encoding. So first I select the variables that I have in my dataset that I want to encode are these three, and then I just apply fit transform in each one of those columns. And then I convert the output of the encoder that is like an array of strings. I convert it into a data frame again with his name, and at the end I create my xtrain and xtest data frame so I can proceed to training my model. Here is to check if I have any missing data because sometimes we have some missing data in our dataset that it was still missing, and as you can see I still have 3 missing data that I haven't cleaned quietly cleaned, so I remove those 3 and move on. Now is when the things got interesting. Now I want to compare my Box-Cox transformation with my log transformation. Which one will give me the better model, the better result? For example, here this is like basic, import the model, initialize the model, train the model. Here I predict. Here I do the inverse transformation. Remember, I have my variable in Box-Cox transformation. I want to go back to my original dollars so I can see how well my model behaves. If we make our R2 score, mean square score, and absolutely mean absolute error, we will see that we have an R square score of 0.78%. At the first sight, you can see like, wow, this is like a really good model. It can explain like almost 70% of the prices of all my dataset. That's awesome. And the mean absolute error is about $71. This is a great model. But what happened with the real R square? The real R square is that once you convert back the model from Box-Cox to real dollars, this one here, what happened? Our real R square score down to 0.33%. So only the 33% of our entire dataset we can explain with this model. This is not bad, but it's not good. So let's try again, but now with the logarithmic transformation. Do the same thing, initialize the model, feed the model, predict. Now that we have predict, we can do exactly the same as Box-Cox. If you can see, my model performs a little bit worse, supposedly, than the Box-Cox, but what happened with the real R square? My real R square is go from 33% to 41%. So for this scenario that we are, the logarithmic transformation performs way better than the Box-Cox transformation, giving us a 41% of our square. And that's it. I hope you find this video interesting. I will, as I mentioned, I will leave the code down below. This wasn't like a video to try to learn how to do this. This is more like an explanatory video. I hope you enjoy it, and I'll see you in the next video. Bye.